Well, thanks for watching. My name is Lance, and I wanted to do a follow-up to a video I did back in January that introduced the concept of system scope within OpenStack. Today, all we're going to be doing is talking about some of those scope changes, and then also incorporating some default roles work that we introduced back in Rocky. The whole purpose of this video is to kind of share the approach that we're taking, the direction that we're heading, and give operators a better idea of what we're doing to make authorization more granular out of the box for OpenStack deployments. So this demo, we're going to be working with two different Keystone deployments. Both are going to have Keystone Master installed, but the first is going to be configured with legacy RBAC defaults, so something that you would typically see in an older OpenStack deployment. The second one is going to be enforcing scope, and it's also going to be taking advantage of the default roles work that we implemented in Rocky. So a quick note before we get into the demo. When you hear me talk about the term scope, what I really mean is authorization scope. And the easiest way for me to explain what that means is by using role assignments. So for example, in Keystone, you have the ability to give your OpenStack users role assignments on projects and domains. Then they can use those role assignments to get project and domain scoped tokens that they can use to go interact with resources within those projects and domains in other services. In Queens, we added the ability for users to have role assignments on something we call the system, and this is meant to be the deployment system itself. So having that authorization on the system gives you the ability to access system-specific resources. Good examples of system-specific resources are things like services and endpoints in Keystone or hypervisors in Nova. Good examples of domain-specific resources are things like users. When you create a user in Keystone, you have to supply a domain for that user to be namespaced to. And good examples of project-specific resources are things like instances and volumes, where when you create them, they are tracked against a specific project. So what we have here are really three different scopes: system scope, domain scope, and project scope. That said, we're going to focus on user management in this demo, and the reason why I picked users is because they're a domain-specific resource. So we're going to see how those three different scopes interact with the user API in older environments, and then also environments that are enforcing scope checking. Now we can take a quick look at our profiles that we'll be using for this demo. All of this is encapsulated in clouds.yaml, and we'll be using at least two different users. We have an administrator who is denoted as an admin because they have the admin role on a project called admin. Kind of overloaded, but keep in mind we're not taking into account system scope at this point. We also have a domain administrator who has one role assignment, and that's a admin role on a domain. So we're going to kind of see how that user is able to interact with domain-specific resources. And we can confirm all this information by taking a quick look at our role assignments. So let's start getting into some user management, and we're going to start with the admin profile, so somebody who is a system administrator in your deployment. You can see here that they can create users, and that's something that you would expect from operators. But keep in mind that that user we just created is in the default domain, which our domain administrator doesn't have any authorization on. They have the admin role on a different domain. And you can see here every user that we have in the deployment. When we go to list users as our system admin or the administrator, you can see everybody that we have in the deployment. But what happens now when you start accessing those same APIs with the domain admin account? So you see our domain admin gets the same response that our cloud administrator got, and that's unintended because some of these users actually live in different domains than what the domain admin has authorization to access. So we're giving too much information away. And this is ultimately because our domain administrator has the admin role, but we're not checking what they have that admin role on. Is it a project, a domain, or something else? And that causes some issues with how we're filtering our response before we give it back to that user. You can also see this bleed through to other parts of the user API. Not only can domain admins list users that are outside of their domain, but they can actually delete users that are in other domains or inject users into domains they don't have authorization on. Unfortunately, because this is how things worked out of the box, it forces operators to maintain fixes for this behavior in customized policy files, which means you have the maintenance burden that goes with that, and also verifying manually that you're not opening up holes in other parts of your APIs because of a policy that you had to override. So scope checking really helps try and fix this by building some of that logic into the service itself and ultimately trying to simplify some of these complex overridden policies. If we move over to our second environment, and this is where we will be enforcing scope checking, we can take a look at some of the profiles that we have. We have 9 different ones to play with, and the reason why there are 9 is because we have 3 different scopes: system, domain, and project. And we also have 3 different roles as of the Rocky release: admin, member, and reader. Right off the bat, you can see we have a system admin role, and this is reserved as the cloud admin, essentially. So somebody who has the ability to kind of do anything within the deployment over the API. We also have system members who have authorization to system-specific resources, but they can't perform create or delete operations. They're limited to listing and updating of resources. And then we also have a system reader, and this is somebody who has just read-only access to system stuff. So we've applied those 3 roles to domain scope and also project scope. And this gives us 9 different profiles to use to interact with the user API. We can verify this information using the Role Assignments API, but it's pretty straightforward. The user name corresponds to the profiles that we just went through. Let's start with user management using our system profiles. So first, we'll create a user as our system admin. Next, we can use our system reader profile, which is just a user with a reader role on the system, and we can retrieve every user in the deployment, which is really nice, especially for auditing purposes. Next, let's try and update one of our users. Let's say we want to include an email address for the user that we just created. And let's try that as a system reader. And this is going to fail because system readers don't have write authorization for system-specific resources. But when we do the same command as a system member, it should work. And we can verify that by using a system reader to fetch that specific user and seeing that change was applied. We're going to go through the same thing, but using it to delete users. Here, system readers shouldn't be able to do this for the same reason. They can't make writable changes, and neither can system members. But when we try the command with a system admin, or somebody who has admin on the system itself, you should see it work. So this really showcases how the 3 roles work for system administrators and the user API. Let's start going through the same flow, but using our domain profiles instead. And in our previous example, this is where things started to break down because we weren't enforcing scope checking. As a domain administrator, we would expect to get back only a list of users that are within our domain. And that's exactly what happens, which is great because we're not leaking any information about other users in the deployment that this domain administrator shouldn't know about. And we see that same behavior applied to domain members and domain readers. So we're breaking the same roles down across the domain scope as we did for a system scope. Now if we try to create a user in a domain that we don't have any authorization on, we actually see that fail. If we don't try and inject that user into a domain that we're not authorized to access, that user is going to assume the same domain for ownership that we have authorization on. And just like with system members, we can use domain members to update users within our domain. We can also use domain readers to allow read-only access to users within our domain too. Remember that we also have some project profiles, some users with admin, member, and reader on a project. So let's try and use those profiles with this API too. Here we actually see that just because somebody is an admin on a project, they actually can't list users, which is nice because remember that users are a domain-specific resource and we're operating outside of that scope, or in a different scope, actually. This same behavior is applied to project admins, project readers, and project members, all because they have the same scope. Well, that wraps up this demo. I hope it was helpful, especially for explaining what the different scopes are in Keystone and how enforcing on scope type can actually make API authorization more flexible and more secure. If you have any questions, feel free to send a note to the OpenStack dev mailing list, or you can always find us on IRC. We're in OpenStack Keystone on Freenode. Thank you.